started. Hello, everybody. Welcome to OpenCV Weekly Webinar. And today I have with us two members of the OpenVINO team, Kumar Vishwas, who is the Technical Product Manager, and Chandrakant Khandelwal, who is the AI Framework Engineer at OpenVINO. And they are going to talk about OpenVINO integration with TensorFlow today. And this is something I did not know about, frankly. I mean, we use TensorFlow all the time. We use OpenVINO all the time. We simply never have used OpenVINO integration with TensorFlow. So I'm very excited because I'm going to learn myself something new. So before we move on to introductions from Kumar Vishwesh and Chandrakant, I want to introduce Phil Nelson, who is the Director of Content and Creative at OpenCV. And he's responsible for putting together the webinar. There's a lot of other things at OpenCV. All the creative work that comes out of OpenCV is Phil. Welcome, Phil.
Yeah, thanks, Satya. Hey there, hi there, ho there. You're as welcome as can be to OpenCV Weekly Webinar, episode 66, if you can believe it. I am Phil Nelson, the co-host with the co-most, the second banana who is second to none, your plus one and only. And I'm here to remind you of a few things we do every single week here on OpenCV Weekly Webinar. One of those things is we take Q&A from you in the audience at any time during the show. Ask your question in the chat section or wherever you're watching us online, or the Zoom Q&A button at the bottom of your window there. We'll do our best to ask those questions of our guests or of Satya or myself during the show. We'll also be doing a special giveaway of the OpenCV course of the winner's choosing to one lucky viewer in the Zoom audience. If you're not in Zoom, you can get there by going to opencv.live. You still got time to join before our giveaway. Back to you, Satya.
Thank you. Thank you. So now I'm going to hand over the stage to our guests. And, Kumar and Chandrakant, if you could start by giving an introduction. Let's start with Kumar. And then we will go over to the slides and learn something new today.
Yeah. Well, hi, everyone. Very excited to be here and talk about the product that I drive as a technical product manager at Intel. And about me, before Intel, I used to work for one of the big three strategy consulting firm. And I took up this project a year back, and now I'll talk about this. Looking forward to the session.
Welcome, Kumar. Chandrakant.
Hi, everyone. Thanks, Satya. Hi, everyone. Chandrakant here, and I work as an AI framework engineer at Intel. I'm working here from last 2 years. And from background point of view, so I'm working in the domain of computer vision from last 12 years and being worked on till now on the application side of deep learning. And then here at Intel, I'm working on the inference side and developing the backend ecosystem.
That's great. I have a question for you. What does your title is AI Framework Engineer? What does an AI Framework Engineer do, and what qualifications do people need to become an AI Framework Engineer? What background?
Sure. So coming to my background, so I have done a bachelor's in electronics and telecommunication, and then I did my master's in applied mathematics with my master's research from CVC Computer Vision Center, which is in Barcelona. And here what AI framework engineer at Intel does is there are a variety of Intel hardware and devices, and then we have a very large plethora of libraries which everyone can use, which are open source to accelerate their workload on Intel hardware. Mm-hmm. And the AI framework team basically works on, so we have OpenVINO as our marquee product, which is you can use as a standalone product, and if your model can from any framework, you can just take it and you can deploy it. Mm-hmm. And the framework integration team, what it is doing, it is taking the power of OpenVINO to all this framework itself. So that all those users which has maybe for some of the reasons, if they are not able to move to OpenVINO, they can use these products and they can still leverage the power of OpenVINO.
Right. All right, great. So let's start with the presentation.
Yeah, so I'm going to share my screen. Hope you can see my screen.
Looks great.
Yeah. So hi, everyone. This webinar will be focused on the product called OpenVINO integration with TensorFlow. There's a lot that you can take away from the name. It has OpenVINO and TensorFlow. Before going through the slides, I just want to talk about what was the thought process behind this product. We wanted to bring OpenVINO and TensorFlow so close that it appears one to the users or the TensorFlow developers. So having said that, let's look at the topics we are going to touch upon. We'll talk about popular AI use cases. Then we'll talk about what is the difference between training and inference in ML lifecycle. Then some major challenges in deep learning. Then we'll give a quick review of OpenVINO toolkit. Then this sets the background. Then we'll introduce the product in focus for this session, OpenVINO integration with TensorFlow. After that, we'll talk about the workflow. That will be pretty simple. Then we'll talk about the platform, Docker, and operating system that we support. After that, we'll talk about architecture of OpenVINO integration with Tensor. What is there under the hood, which is powering this tool? Then we'll show a very interesting demo that will show the capability of the product. Then we'll share some resources. That's the plan. So let's start. So well, AI use cases across various domains. We know that AI is rampant nowadays, right? In be it manufacturing, healthcare, agriculture, retail, you can see AI applications there. If I talk about manufacturing, we can do some sort of visual inspection. We can detect a mask, helmet, those by analyzing video feeds. In healthcare, we can analyze MRI scans and make judgment out of that. In agriculture sector also, we see a lot of AI use cases. The most simple one would be animal monitoring. If I have a large farm, I can set up a camera. I can analyze the feed of the camera which is facing a lot of cattle, and I can maintain the count of them by using the object detection algorithms. Similarly, in retail, I can do the monitoring of the inventory, and the moment anything gets stocked out, the automated order can be placed. So those kind of cool use cases are there that requires quick inferencing, and our tool is focused on that. So let's talk about training and inference. Machine learning, in the machine learning life cycle, we have two distinct phases. One is training, second is inference. Training is same like we can relate the training to human life as well. Like human beings, they get trained so that they can do something. I get education so that I can perform well in my job. I can do the task quickly. Similarly, the same analogy here, we have an untrained model, then we take training data set, we select the deep learning framework of our choice, for example, TensorFlow, then the model gets trained. Once the model gets trained, then it goes to real world. It gets new data and it does inference and prediction. Maybe it could be for classifying images or detecting objects in the images. So that is what happens during the inference phase. So this is the clear distinction. Obviously, it is very clear, and it goes without saying, without training, we can't jump to inference. So yeah, there are various challenges in deep learning. First is unique inference need. We know that when we train our model, we train it in large server farms. But but there are many use cases where we have to deploy the same model in low-end devices. There, sometimes we need to do trade-off between performance and accuracy. To get optimal performance, sometimes we might need to lose accuracy and vice versa. Also, there is integration challenge. There is no API in place which connects the training phase and inference phase and facilitates you for the deployment. Also, another point I want to highlight, no one size fits all. Every use case has its own requirement, its own workload requirement. So the solution becomes very use case specific in these scenarios. Now, moving on. So there comes OpenVINO toolkit. We'll give a quick overview of this. This toolkit caters various AI frameworks. You bring your model, that model could be trained in TensorFlow, Keras, Cafe, MXNet, any AI framework. And then with OpenVINO toolkit, you accelerate the inferencing speed, and then also it facilitates you to utilize any of the Intel compute devices, and plus provides you flexibility of running it on various operating systems. So this is a very powerful tool uh, that most of you must have heard of this tool. Let's talk about typical workflow in OpenVINO toolkit. So basically what happens in this workflow, you have a trained model. Then in the OpenVINO toolkit, we have a open model optimizer that converts the model into intermediate representation. Some optimization happens there, and then that intermediate representation of the model uh, gets deployed on inference engine, and that runs the workload and across various Intel devices. So there are a couple of APIs that we need to learn: model optimizer, inference engine, and there's a model conversion that is happening here, where from the native AI framework, for example, TensorFlow, that model gets converted into intermediate representation after some optimization. So this is typical workflow of from development to deployment in OpenVINO
Yeah.
toolkit.
Yeah,
Yeah.
just so people who are not familiar with this pipeline, the the main goal of the difference between training and inference is obviously that during training we use as much resources as possible. The final model that we produce could be actually very large. That model could be hundreds of megabytes sometimes, but during inference, when we actually want to use that model, we do not want to carry all the information that was in the model during training to the inference phase. The easy pieces are that this model could contain a lot of gradient information that is used for training, but is no longer for necessary for inference. So that's the straightforward part. There are parts which are only used for training, which are removed in the final inference frozen model. But there are other optimizations also. For example, if you're running this model on a GPU, and let's say the GPU supports a 16-bit floating point precision, in that case, instead of using 32 bits, you could actually change it to 16-bit floating point precision, which not only changes the size of the model, it makes the model smaller, but it also allows you to use the special cores in the GPU specifically made for 16-bit processing. So you get blazingly fast inference on the, when you're using the model in real world, it becomes blazingly fast, and also it becomes smaller, right? And then there are other kinds of optimizations you can do based on how the model has been trained. You can look at a neural network and see that, oh, parts of the neural network are completely useless because the weights are 0, for example, and you prune out, you remove those parts of the neural network which actually were not used. It was part of the initial architecture, but when you actually do the calculations, you see that those parts do not contribute to the final result, or contribute very less to the final result. So you can prune out those parts of the neural network and make it smaller. So the whole point of this pipeline is to take a model that you had trained and make it smaller and faster so that it can run on edge devices or even simple devices. It frees up computational power, frees up memory that needs to be used by this model. And that's the whole point of inference engines like OpenVINO, that they allow you to use these trained models and make it very efficient to run on these edge devices or the place where you're trying to run. The other thing I want to say is that there are two parts to this OpenVINO. One is that you convert any model. You can train the model in PyTorch, you can train it in TensorFlow. You convert it to a representation that is optimized. So that's why you have this model optimizer, which converts it to something called intermediate representation. And this is a binary file that the OpenVINO inference engine understands. And for every platform, you would have a different inference engine, and it understands what are the various optimizations it can do on the platform itself. For example, if I'm running it on an Intel CPU, it will use some optimizations. Maybe it knows something about the core, about the architecture of the CPU, and it efficiently allocates memory and things like that. It could be using, it could also, the same model could be running on Intel VPU, like the chip inside OpenCV AI Kit. And there, it would use a different kind of optimization, right? So that's the job of the inference engine, to take the optimized model stored as intermediate representation and run efficiently on these various devices. So that's, I just wanted to lay it out for everybody who, even beginners who do not understand the whole pipeline. Yeah.
I think there's
carry
also an important note here for the audience, which is one of the best devices that is an Intel, it contains Intel accelerated hardware, is the OpenCV AI Kit, which has an Intel Movidius X inside.
Yep.
Yeah. Hey, thanks for a great explanation. Having said that, just for the beginners again, by now you must have understood that OpenVINO is a very powerful toolkit. It is kind of a superpower, right?
Yeah.
And it is it has a lot of functionalities, a lot of control you get. So let's move on, and we have another thing coming for you. Yeah. Well, as explained by Satya in the last slide, uh, we saw that there are three sort of learning curves, I would say, in the typical workflow. First is offline model conversion that used to happen through model optimizer. Also, we want to talk about a section of user TensorFlow developers who are very new, beginner, and who don't want to learn new API, or who don't uh, understand the OpenVINO complexity, or they don't have they have time crunch, or they want to quickly utilize OpenVINO toolkit optimization. So that section of users will be catered through our solution. Another thing I'll talk about, they are just to use any model in OpenVINO toolkit. If out of the box, then the whole topology of the model should be supported by OpenVINO. Maybe the operator supported. If some of the operators are present in the model are not supported, then we do have option to write custom functions for model optimizer and inference engine. But out of the box, if the whole topology is not supported, then it leads to limited model coverage. And how we are going to solve these three problems, that will see through the product in focus, OpenVINO integration with TensorFlow. So well, till now, if you are not fully aware of OpenVINO toolkit, or you didn't understand because you are a beginner and you didn't understand the complexity and all the APIs involved, still you want to quickly start with OpenVINO toolkit utilization, here is the tool for you. OpenVINO integration with TensorFlow. What does it require? It requires you to know about TensorFlow. We assume that you only know about TensorFlow. We are not saying to come out of your comfort zone, that is TensorFlow ecosystem will bring OpenVINO toolkit optimization inside TensorFlow ecosystem. How it will happen, that I'll talk about in a moment. In the code snippet, you can see that it's a typical TensorFlow code where you load a model, you resize the input, and then finally in the last line you call model.predict. These are all TensorFlow APIs. If you had observed this minutely, you'll spot there are two different lines of code. First line is importing a module called OpenVINO TensorFlow. After installing through pip, you can have this module in your code base. Then you set a backend, maybe GPU, CPU, Myriad, VADM. So these are the options that you can set, and that's it. Your model will remain as it is. You'll get that will get accelerated, and that's all. So our tagline is existing TensorFlow code, add couple of lines of code, then your model will be boosted with accelerated inferencing on Intel hardware. So what it is, yeah,
When you say GPU, does it also mean NVIDIA GPU or Intel GPU only?
Intel
Okay.
hardware.
Yeah. Okay.
So GPU is one of the argument which you can pass in the function.
Great.
So what it is, so by now we have understood like it enables OpenVINO acceleration with TensorFlow API. And user remains in the TensorFlow ecosystem. 2 lines of code, it's a low code solution. All the complexity of OpenVINO toolkit is abstracted behind these 2 lines. The inline conversion of the model happens for you the model to just to utilize OpenVINO toolkit optimization. You don't need to convert your model. Everything is taken care by backend. Also, if you are a startup or you have time crunch or you are operating with very lean capacity, then you can immediately get acceleration. Then the other point I touched upon in the last slide as well, limited model coverage. Even if some of the subgraphs we are not supported by OpenVINO, then those subgraphs will be dispatched to native stock TensorFlow runtime. That we call it dynamic fallback feature that we'll talk about later. So yeah, so these are the benefits, and this is the product, and you understood like it requires less effort, and you can immediately get acceleration.
Right. So when you say there's a new processor, right? Intel's Kimbe. For optimizing for that, will we use Myriad, or what is the option? Do you know?
Uh, uh, for Kimbe, we have not yet validated,
Okay.
but that is part of our roadmap.
Okay.
Then we'll figure out that stuff. Yeah. So well, we know that OpenVINO toolkit is for high performance and accelerated deep learning inference. It provides streamlined development and it provides ease to the developers. And here the focus I'll talk about, because we talked about 2 alternate paths. One is being in the TensorFlow ecosystem, utilize OpenVINO integration with TensorFlow. The second path is take your model, which got trained in TensorFlow or be it any other framework, convert it into intermediate representation and follow the route of a native OpenVINO toolkit by learning that and mastering that, right?
Mhm.
So well, the main product differentiation here is for better performance and for more control over the toolkit. It's recommended to go ahead with OpenVINO native API. But if your requirement is to be in the TensorFlow ecosystem, uh, and you want the solution to be compatible with TensorFlow ecosystem, then we suggest OpenVINO integration with TensorFlow. For example, suppose you have a pipeline setup that is for incremental learning, frequent incremental learning, that is set up in the native framework. Then it might take you some time to move away, and every time model gets updated. So there, being in that ecosystem, you can leverage OpenVINO integration with TensorFlow. And also, like it depends on the time crunch as well.
Right. Does it also mean that, let's say you have some new layers have come up, right? Some model is using some new layer which is not part of OpenVINO yet. So in the interim, you could use OpenVINO integration, and when the model gets fully supported by OpenVINO, then you switch over to. Is that correct, or
Well, the moment OpenVINO supports an operator, will
Yeah.
also be supporting. Okay, but
Right.
the portion of the model which is not supported,
Mhm.
uh, that will get dispatched to native stock TensorFlow runtime. But the
Right.
portion which is supported, that should be accelerated, and that is where our tools comes into picture. No error, nothing, but
Right.
whatever is supported can be accelerated, will be accelerated, and we'll
Right.
talk about this in detail. Uh,
But let's say some new components are there, some new layers are there, which are not supported by OpenVINO. In that case, if you try to use the native path, the first path, then it will not work, right? Because you'll have to write custom layers and things like that.
Correct.
Okay.
You
But
get
with
that
OpenVINO
error.
integration, it will still work. It may not be as optimized, but it will still work, and parts of it will be optimized. Is that correct?
Perfect. Perfect. Yeah.
Okay.
Well, we often see that unsupported operator exception message, right?
Yeah.
And those things. And also writing, because it is mainly for beginners and to quickly start with, right? For beginners, sometimes we have seen they face difficulty in understanding the mathematics behind the model. And that
Yeah.
is required if you are writing custom function for model optimizer or inference engine.
Right.
So yeah, the workflow, it's very straightforward: pick, enable, run. Pick a TensorFlow model, enable OpenVINO backend, run it using TensorFlow API, that is your comfort zone. So well, pick a TensorFlow model. We have 450 plus models supported from TF Hub, TF Model Garden, OMZ models, and the performance acceleration for each supported model, the extent of support, we are improving with each release. So yeah, so we cover a lot of model. Then enabling OpenVINO backend. In your existing code, you just add 2 lines of code. Then running it, here I was talking about the process. We have a dedicated session for the architecture that will double click on this, but I'll give you a brief overview. We have a TensorFlow graph. What happens behind those 2 lines of code? Then that TensorFlow graph gets we do subgraph partitioning, and then we get a lot of subgraphs out of that. Those subgraphs which are supported by OpenVINO inference engine to get accelerated, those will be dispatched to OpenVINO inference engine. Those subgraphs which are not, those will be dispatched to TensorFlow inference engine. So we are making use of both the inference engine efficiently so that the solution becomes robust. Users, they don't have to think about the complexity. Everything is abstracted, a low code solution that handles the error and provides the acceleration quickly.
Mm-hmm.
So well, let's talk about the platform that we support: Intel CPUs, integrated GPUs, Movidius, Myriad. Uh, we also have our pre-built images on Docker Hub, and you can find Docker files in our details in our GitHub pages. Also, I want to highlight about TensorFlow serving. Think about a typical TensorFlow developer. A go-to choice for a typical TensorFlow developer, if he or she wants to be connected to TensorFlow ecosystem, then to serve their model, they might use TensorFlow serving. And that is a big emerging community, right? I remember my days when I had to write Flask code where I had to wrap up all the functions, right? But TensorFlow had made a lot the life easier, and we have pre-built Docker images that supports TensorFlow serving workflow. Plus, it will also provide you OpenVINO toolkit optimization. So, for example, if you have a setup where you are utilizing TensorFlow serving, if you replace that Docker image with OVTF plus TensorFlow serving Docker image, you'll be instantly be able to utilize OpenVINO toolkit optimization without doing anything extra, just changing the Docker image which you're using. Because our Docker image supports everything that TensorFlow serving supports, and on top of that, we provide OpenVINO toolkit optimization. Yeah, and OS support, we support Ubuntu, Windows, and yeah, these are the basic details. Once you search for OpenVINO integration with TensorFlow in our GitHub, everything is well laid out. You'll find it very easy to learn about it and experiment with the product.
Yeah, it's literally 2 lines of code.
Yeah. So now I'll hand it over to CK. He'll deep dive into the architecture. I talked about all those things which happens behind those 2 lines of code, that he'll double click on that. Yeah, CK, stage is yours.
And as a quick reminder to everybody out there in the audience, we are taking your questions later in the show, so go ahead and send those in the chat or wherever you're watching, or use the Zoom Q&A button, and we'll get to as many as we can at the end of the episode.
Thank you, Kumar. So I'll take a deep dive on the architecture of it. So on the top layer, we have TensorFlow, and then the control is with the TensorFlow, as you see. And then TensorFlow has a very, like, you can implement or add extra passes to TensorFlow by extending their classes. So in this OpenVINO TensorFlow, what we have done is we have added it as an extra optimizations pass. So when TensorFlow runs all the passes, we have registered our pass too, and then it gets called. And what happens is, like, when it is called, we get the handover of the TensorFlow graph. And then what we do is we pass that graph, and we have another model, which is operator capability manager. And what happens is we pass is that like model op by op, and then we this model does is, like, it checks whether the latest OpenVINO ops is supported, whether this op is supported or not supported. And there, it's not just straightforward like an op to op mapping, because there is no one-to-one op mapping from TensorFlow to OpenVINO. So there's a combination of op, and there are certain patterns which we need to check based on certain inputs and certain conditions. So this all, like, the decisions are taken at this model itself. And once it, and again, like this operator support, it varies from device to device. What support you have for CPU might not be there for Myriad, or might not be there for GPU. That's so it does take care of your device too. Once you do the setback, and it gets the device, and it then does that. And then what it does is at the next level, it gives all this information to the graph partitioner model. And graph partitioner, it's an intelligent model. What it does is it goes through the graph, and then it says, okay, what ops are supported and it was not. For example, in the right hand side, there's a demonstration where you said that there's a select op which is not marked as supported, right? So what it has done is this graph partition, it has divided your whole graph into 2 clusters. It will try to maximize those clusters. And then you have cluster 0, cluster 1, and then there is a select op which is not supported. Now, once this cluster information, everything is marked, then this information is passed on to your next, which is TensorFlow importer. And here, what happens is, so in TensorFlow, what you can do is, like, you can implement your custom ops, right? And then you can have their custom op implementation. So each of these cluster is implemented as a custom op. And then, we take this cluster and we translate this cluster in line from TensorFlow ops to an corresponding, like, OpenVINO ops. And then it is intrinsically, or like without, like, doing explicitly, is converted to an IR representation. So this conversion happens, and there is a model within the code, which what it does is it takes the op, it finds all the inputs and output, it does the translation, it sets up all this thing. And then we get this internal OpenVINO representation from the TensorFlow representation. And then what happens is, next slide, please.
Yeah.
Okay. So now, once you have converted all those like clusters to OpenVINO representation, and now when TensorFlow is executing, what TensorFlow does is it looks at the each op, right? And then it tries to execute it. Now for this ops, or let's say with subgraph, which are marked as supported by OpenVINO, it will give handover to the OpenVINO TensorFlow, and it will execute all of them, right? And then you might have seen, like, there's a cluster 0, so cluster 0 is executed, and then the handover is given back to TensorFlow, which will do that one of execution or whatever parts which are not supported, and then it does execute that. And then again, you see that there's a cluster 1, and for cluster 1, it sees that, okay, this is a custom, marked as a custom op, and it can be executed. There is a custom kernel for it, and it does give handover to that custom kernel executed, the compute part of that, and then that is executed. And again, the final output is handed over to TensorFlow. And then this is all happening in the background. User doesn't need to know. TensorFlow has a very good ecosystem to add custom passes as well as implement custom kernels. And this is done in that. And what backend manager does is, based on you have the set the backend. So it uses the OpenVINO libraries and OpenVINO C++ APIs, and then use what you use as a standalone in an inference application or C++. It uses even like a same thing like what you is in the under the hood of those APIs, and then it calls those APIs, and then runs the cluster on the set backend, which is could be CPU, iGPU, or Myriad, or even VADM, which is like a combination of 8 VPUs. So the underhood you see from backend manager to all the device scheduling, that is all handled using the OpenVINO library. So there is no like whatever existing OpenVINO, like the binary package you get, we use the same to compile our OpenVINO TensorFlow, and then the same libraries are being used to manage this support. So this is, and if the graph is completely supported, you will see a good performance boost. But the thing is, as it is an like an integration, and there are some overhead of doing to and for back and forth. So you might see that there could be some difference between what you see on OpenVINO and what you see through this OpenVINO TensorFlow.
Is there a chance that the performance would degrade for some cases? Should users watch out for that as well?
So degrade in terms of TensorFlow, like whether it...
Yeah, compared to TensorFlow, like is there a situation where the TensorFlow engine is actually better than OpenVINO TensorFlow integration, or you can pretty much assume that that's never going to be the case? It will, the worst case is that it will fall back to TensorFlow engine. My point is that, are there overheads, communication overheads, or some kinds of overheads which make this OpenVINO integration with TensorFlow worse in small number of cases, or that almost never happens?
You're absolutely correct. It can happen because, for example, when you see that there are many such 2 and 4 happen, then there are the overheads become really larger than the optimization achieved, and in that cases you can see such a degradation that okay, it could be like 5% or 10% less than TF. But then to give you a current state, so for most of the CV use cases, which is related to, like you say, image classification, object detection, semantic segmentation, on an average of maybe 70 to 80% cases, we have made sure that we are better than TensorFlow. And then, as it is in like continuously developed product, we like continuously improving it with release after release.
Right. And the test is easy, right? I mean, in case you suspect that it is not doing better, you can simply turn off 2 lines of code. It's not like you have to massively change your code. You can turn off 2 lines of code, comment it, and test again, right?
Yeah, that's the beauty of it. Yeah,
we have another API, dot enable, dot disable.
Oh,
that
okay. Right. Right.
And having said that, we have done some improvement. CK, do you want to double click on the rewrite pass that additional check we had implemented this with this release?
Sure. Yeah. So, so whatever you have said, Satya, so to handle such situations, it can happen that for a subgraph or for a, if TF is really faster, and which can happen because TensorFlow is from 2.9.1 is now 1DNN powered, right? And then that also does intrinsically is providing empowering OpenVINO to perform better on the Intel devices. So in that case, we do that internal comparison, and in that case, we try to hand that cluster back to TensorFlow. So there's a smart decision being made, and to like is give the user best out of both worlds. So we make such a smart decision. But even in that case, for example, in such cases, if that cluster is really small and the overheads are really high, then even that handover becomes expensive, and then the overhead can cost. So which is it could be case for smaller models, maybe you have like new topologies, which like, for example, in case of NLP models right now, there are new topologies every other month. So in that case, you might see such things.
Yeah, so let's move to the more practical part, demo.
Okay. Is this
well, I'll stop sharing.
A brave live demo?
Yeah, but it will be definitely tempting to a lot of TensorFlow developers. I can vouch for that. Yeah, CK, you can share your screen.
Sure, I'll share my screen. There's a transition of screen share here. Uh, uh, let me know if it is visible.
Yeah, it appeared.
Good.
Okay. So let's hide it. Okay, so I have opened a page which is a live demo on the Intel Dev Cloud. So
Mhm.
can I hide this panel? And
Phil, it may be useful if, I think Intel Dev Cloud is free for people, right, to use?
yes, so I'll quickly go over the dev cloud part. So
Yeah.
this is available like devcloud.intel.com, and then
I'll drop the
you
link in there.
can,
Yep.
yeah, so this is there, and then you can see there that they have like various options for user to use it based on their requirements. So there's the container-based workload, which is like you can bring your own containers and then you can deploy them, and you can even before even trying to decide which really the system or the combination you need, you can use it to decide.
Mhm.
And then the second thing is Jupyter Lab, which is like brings the power of Jupyter notebooks to your to the user.
Yeah.
So if you click on the Jupyter Labs, it will take you to the like what all options are available, and then here you can find that open integration with TensorFlow is provided.
Mhm.
And if you click on that, it will take you to right now some of the samples which we have presented. So I've
Great.
opened one of the sample, which is like object detection notebook. And in this, what I'll be doing is I'll showcase a very simple example of YOLO v4, and we'll see the comparison of YOLO v4 on CPU with the stock TensorFlow. I'll be like using stock TensorFlow and native TensorFlow interchangeably. Please forgive me for that.
Okay.
And then
And one other question, with Intel Dev Cloud, you can, let's say you don't have a Movidius, neural compute stick, and you want to test your model on that. The Intel Dev Cloud supports that, right? Those kinds of hardware.
Sure, sure. Yeah, it does. I'll later, like in some section, I'll also introduce like how to list out all the nodes available and how can you run your workload on those edge nodes. So
Okay.
that, yeah, sure. So in this notebook, for this there's a standard TensorFlow code which is like used to run YOLO v4 model, and then and that's a publicly trained model on Cocoa dataset, and we'll be running it through various combinations of devices and libraries. So
Yeah.
I'm just in the downloading the like any open source YOLO v4 model, and then the rest of the code which you're seeing, it's just an directly taken to run the YOLO v4 model, and these are all helper script, so you can simply run them for the sake of simplicity, and for I have already pre-run this notebook to avoid any glitch at runtime.
Yeah.
And
CK, so if you could slow down just a little bit so that people can follow through.
mhm.
That would be just a little bit. If you could slow down, that would be great.
Sure.
Yeah.
Yeah. Thank you for the feedback.
Yeah.
Sure. So in this notebook, I'll just quickly summarize. I'll be it showcase that how to execute a YOLO v4 model. It's a publicly trained model on Cocoa dataset, and then later on it will show you that how to run them on the available edge nodes on the Intel Dev Cloud, and how you can run your script and you can get your results, and then you can really use them to decide on your like what kind of workload you want to design or what kind of system you want to use. So this is an end-to-end notebook to showcase the same capability.
Okay. So YOLO v4 we are downloading, and then we are running. This notebook is essentially running YOLO v4, which is an object detector, trained on MS Cocoa, which means that it will detect about 80 objects, right?
Exactly.
Okay.
Yeah. So here there are like a couple of more things, that the 2 lines of code which like for advanced user or those who want to even get more performance than so there are a couple of environment variables which can be useful in certain condition. For example, I'll come back a little bit to TensorFlow 1 and TensorFlow 2. So in case of TensorFlow 1, we remember that we used to have a model, and then we used to freeze it for optimal inference, right?
Mhm.
And that in that freezing part, what we were doing is we were converting all variable to constant to minimize your peripherals or all unrequired part which is not useful at the time of inference, right? In case of TF2, the TensorFlow doesn't have a publicly available API, but then internally they do have this facility where you can advanced user they use those APIs to optimize their model for inference, right? And which in turn again does the same thing. It takes your saved model and then it convert all the required part into constants or maybe chop that off, right, for inference. So such similar facility we have through OVTF also, because the user might not be aware of it or might not want to do it or may not be because of any other constraint is able to do it. So they can enable this environment variable, which in turn would do that for the user. And by doing this, if your model is not already optimized for inference for the TF case, it will internally does that part for you, and it will give you an extra acceleration.
Okay, so by default, is it a good idea to do it, or the OpenVINO TF convert variable to constants? This is set to 1. Is this a good default, or people should do it as a second step when they want additional optimization, or this is safe enough to be done always?
So I would say if it is used as a default step, then it's I will advise it to use as a default step.
Okay, so you advise it to use as a default step.
Sure. The reason why we have not included it as a default step, because once you do that, you cannot change your weights after that, because once you your topology has been changed a little bit, and if you try to load a new weight file in the runtime after doing this, then that won't take into
Right.
effect, and that's why we don't do it, because we want user to consciously do it, understand it, and then do it.
Got it. So this is, for people who don't remember, TensorFlow used to have this idea of freezing the model. So when you freeze the model, the weights cannot be changed. And this is doing exactly what that once you, so there are two parts to a neural network. It is the architecture, which tells us, what are the various layers, etc., that are present. And then there are the weights, which tell us what are the values in those what are the values, what are the parameters for those layers, etc. Now, if you freeze during inference, we don't change the model weights, but it may be possible that in your code you are changing the model weights for some reason or the other, even during inference. And if you want to freeze the weights, using this line of code ensures that you're actually not changing them, right? And the reason it is not enabled by default is that some people might actually be doing, changing weights even during inference. But if they do it consciously by, by enabling this, by having this option of freezing the model, they are consciously telling that the model weights are not changing. Is that a good summary?
Yes, Satya, that's
Okay.
absolutely correct.
Okay.
The other environment variable which you see is we are enabling 1DNN optimization, which is till TF 2.8 release, they were optional. And then from the latest 2.9 release, we don't need to enable this optimization through environment variable. They are by default enabled. So in this demo, we are using TensorFlow 2.8, and that's why I have provided an extra environment variable. And this is to speed up those ops or subgraph which are falling back on TensorFlow, so that you get best of both worlds.
Okay.
Yeah. Now, the rest of the helpful functions, they are simply to load some of the required files and models, and this run detect. So if somebody is trying it out, wants to try out, it supports both the image mode and the video mode. So they can provide a directory which has all the files, so they can try out this demo itself for their examples. Moving on. So you can see in this demo, we'll be running it on a simple open source image, which is a grasshopper image, and then we will be seeing what are the outputs. there are certain flags which are set. So one thing about DevCloud is, so when you open this Jupyter notebook, what it is open on is called as a dev node, and it's a shared resource. You are onto it, right? And then to use it on the very specific edge nodes, there is a separate ecosystem. So I'll move on to that part. Okay. So they can copy these commands as it is and use them in their IPython notebook. So once you use this, you can see here that it is listing all the edge nodes access available to me, right? In this, where so that the question you ask, you can see that what is the CPU type, or does it has a like Myriad stick or not, or does it has an Intel graphics accelerator or not? So all this information is displayed with the machine information. So you can. And each of these machines has a separate ID, which you can use or which we'll be using later to schedule your workloads onto these edge nodes. So all you have to do is you have to take note of these IDs for the machines which you want to use.
Okay.
And later on, how to run your code into the edge node. So what you have to do is you have to write a bash file, and then bash file you have to write the steps you want to run for your workload. So if you like in this notebook itself, you go to file and then you click on open, it will give you all the Python files available with it. So whatever the code I've shown you in notebook is written in a file to run it for the edge nodes. And this file, so this bash file is like being executed on the edge nodes. So I'm writing this bash file for all different combinations. So for native TensorFlow, for 1DNN TensorFlow, for OpenVINO TensorFlow. So if somebody scrolls this notebook, they could see that what all notebooks are available.
In these pieces of code, you're running OpenVINO, the native TensorFlow, as well as OpenVINO integration with TensorFlow, so that we can compare the results. Is that correct?
Yes, exactly.
Okay.
So, the notebooks I'm providing different options. So you can see, for example, -f with OpenVINO, for that with 1DNN, for that with native TensorFlow. So if you open that Python file or even in this IPython notebook, it is like these options are described, and they can provide this arguments with this file, and then based on these arguments provided, this script would be run for that combination.
Got it. Yeah.
Yeah. So now that TensorFlow supports only CPU, so we have written on the TensorFlow script only for CPUs, but but OVTF or like OpenVINO TensorFlow, we supports all the like 4 devices: CPU, the GPU accelerator, Myriad stick, and as well as the HDDL. Now, once you have written this bash file, what you have to do is we have to. This is a standard way of running your workload on the edge nodes. So you have to run this. There's this set of commands. You have to just simply use them, and then you have to provide your bash script, okay, and the node which you want to use. This is the node ID and the device which you want to use, right? And this.
So the node is the machine which can have multiple devices in it. It could have a CPU, it could have a GPU on it, etc. Right?
Yes. So based on the description we have seen above, based on our requirement, we can select the required node. For example, if you want to run it on Myriad, then select the node which has like Myriad in it. If you want to use it on Xeon server some base, then use the node which has like the Xeon-based Intel processor in it.
Okay.
So, yeah. And then the argument which you are passing, they are passed to the bash file. For example, -f CPU. So this is the device which is being passed to this bash script, and you can see that this is device which is being passed in next step consecutively to this Python file. So I've done this for same for CPU. Then for these are 3 different combinations: native TensorFlow, 1DNN TensorFlow, and OpenVINO TensorFlow. So these are the bash script, and then I'm scheduling them one by one on the edge nodes for the device one to use. Now for OpenVINO TensorFlow, I'm doing not just for CPU, I'm extra doing it for CPU, GPU, Myriad, right? And also for the this VADM, which is we also call it as HDTL, which has 8 vision processing unit. So now once these jobs are submitted, I'm also like to give user a comparison of like how OpenVINO TensorFlow performs vis-a-vis OpenVINO. So I have taken this model and we have provided a script which in turn convert this, does this offline step of converting the model into XML and then running it onto the inference. So just to have an end-to-end comparison that how the performance of TensorFlow on CPU looks, how performance of OpenVINO TensorFlow on CPU looks, and how OpenVINO looks on CPU, just to
Right.
give a
So for
overall.
people who may not have remembered, there are two paths to using OpenVINO. If you know what you're doing, and it is probably better to use OpenVINO directly and optimize the model. And if the model, all the layers are supported, then it's good to use OpenVINO directly, and you have much more control over how much you can optimize the model. But if you are new to this kind of optimization game and you just want to use OpenVINO with TensorFlow without much of a hassle, then you use OpenVINO integration with TensorFlow. And there is also, I mean, you probably already use TensorFlow right now without OpenVINO. So those are the three conditions, right, that we are going to see how they perform against each other. The notebook allows you to do that.
Yeah, and also one point here, like if your model doesn't get converted into IR, you are getting model and supported exception.
Right.
Then
right.
also we can use
That's
this.
right.
Sure. And like this might seems like a lot of odd steps, but then once you go through the notebook, you will see that a lot of them are just repetitive step, and you have to just write what you want to run in the bash file and just load it onto an edge node and just run it. And that's all you are doing. It's just that we are running so many combinations, so you are looking like, okay, there's so many cells which are being just like we are passed through so fast, but they're doing the same thing. Okay. So even for OpenVINO, like we have described that how this bash file can be executed for CPU, GPU, and Myriad and VADM. So for OpenVINO also, because OpenVINO also does support all the devices.
Right.
And then I'll quickly move through the performance comparison part. So where I'm comparing like some of the components, then you could see that on the y-axis is the FPS, so higher the better. And on the x-axis, there are the different the combination we ran on.
Mm-hmm.
So the first you see is the native TensorFlow on CPU, and then the second you see is the OpenVINO TensorFlow on CPU, and the third you see is the native OpenVINO CPU, right? So you can like it's easy to visually compare this combination because all three first bar graphs are running on CPU only, right?
Right.
So yeah, you can see that, okay, OpenVINO TensorFlow is better than native TensorFlow, but then native OpenVINO is still better than OpenVINO TensorFlow, right? So
Right.
that, and the last three bar graphs, we wanted to also showcase that how OpenVINO TensorFlow does support GPU, Myriad, and VADM, and then you also get a good boost if you use those devices.
Yeah.
Sure. Yeah, so that's all is related to the demo part. Yeah.
Awesome. Yeah, we should do our giveaway here, and we've got a ton of questions from the audience today. But yeah, if you wouldn't mind unsharing your screen, I'll do our giveaway.
Do you have a question?
I have a lot of questions.
No, do you have a question for the giveaway?
Oh yeah, definitely.
Okay, great.
Yeah, so go ahead and Kumar, please unshare the screen, or whoever's sharing. I forgot which one of you was sharing. Go ahead and turn
I'm
off the
sharing,
screen
but
share
then
for the moment.
yeah, okay, but someone like all the icons got hidden.
That happens. They may be on a different screen. I'm not sure.
Let me
maybe try focusing Zoom, and it may let you do that. I think I can probably also.
Yeah, you
You can host
turn off
cancel.
this game. Yeah.
How do I do that? I don't actually know.
Maybe CK, you can try pressing escape button, then it will come out of the full screen, and then.
Yeah, I'll just let me see if I can stop here. Okay. I'm going to first share my screen real quick for
Yeah, that's
I have something to remind everybody about. So one of the things that we didn't get to do this week, unfortunately, is folks will have seen last week we have our virtual set with Light Twist. We had some technical issues today, and so we weren't able to broadcast from that set. But I wanted to remind everybody, we are currently asking for your help out there in the audience in naming our feline friend in the studio. I'll give you a quick look. The cat does not currently have a name. We would love if you in the audience would help us. Please send your suggestions to newsletter@opencv.org. We've got one here I'll read from last week from Joni and Mark in BC in Canada. They suggest the name ARTI, A-R-T-I, short for artificial intelligence, which I thought was pretty funny. Thanks, Joni and Mark. Yeah, so send us those suggestions, folks. I'll turn that off.
Why did we decide on a cat, not a dog?
I think the reasons are obvious.
I have no idea.
If you have to ask, you'll never know.
Okay.
Moving on to our trivia giveaway today. So the winner of today's trivia question will get the OpenCV course of their choice. Of course, OpenCV courses are one of the best ways to get started or level up your current career in computer vision and artificial intelligence. You can sign up for those at opencv.org/courses. But the first person to answer the question I'm about to ask you will get one of their choice for free. If you have won recently, as in the last 2 months, please don't answer and give other people a chance to win. I'm looking at you, Partha. I'm looking at you, Richard. We appreciate you, but you're sweeping up over here. So the way this works is I'm going to ask a question based on the slides from the presentation today, and you will answer in the Zoom chat window. The first person to answer correctly to my satisfaction will win this course. So earlier we discussed, earlier we discussed intermediate representations that consisted of an XML file and a binary file. What does the XML file contain? Ooh, that was a good one. I had to level up my game. Richard made fun of me last time. You're close. Be specific. Be specific. There was a phrase we used. Ooh. All right, Mark Johansson. Mark Johansson correctly said the topology of the model. The answer was topology. Congratulations, Mark. Please send one email to phil@opencv.org, and I will make sure that you get the course of your choosing. Go ahead and go to opencv.org/courses, look at what courses are on offer, and if you want to tell me which one you want, we can get you squared away as quickly as possible. Let's move on to questions. We've got a ton. We've got a ton of questions. Do we still have slides to go through, guys, or are we done with slides?
Finally, I'll take 30 seconds to talk about the resources.
Yeah.
And other things.
Yeah, we'll go ahead and finish those, and then we'll move on to a couple of questions here.
Yeah.
Go right ahead.
So, well, if you search for, hope you can see my screen, right?
Yep,
Yes.
we can.
Yeah, so when you search for OpenVINO and TensorFlow, most probably you'll land up to this GitHub page, OpenVINO TensorFlow. Here we have a good README that you can read and know about the product. All the details are here. Here you can go inside the examples folder. You can look at we have Python samples, plus we have notebooks that you can run it on your browser. You can also get into a folder called Docker. There you can have details of the Docker images, plus the TensorFlow serving a workflow. And after this, what if you are not TensorFlow developer? So we have similar framework integration for Onyx runtime developers and PyTorch developers. For Onyx runtime, we have Onyx OVEP, OpenVINO execution provider. And for PyTorch developer, we have OpenVINO Torch ORT. Well, from our OpenVINO AI framework integration umbrella, we have offering for other framework developers as well. So yeah, that's it. I'll take a pause and let's attack questions.
Awesome.
A quick
Yeah,
addition to
Go ahead,
to
CK.
Kumar's point. So those who are like very fond of deploying their workloads using containers, and then if they're using TF serving and they say, okay, we want to use it in TF serving, which is majorly C++ based, or how to like the C TF server is already available as an image, or you can pull the code and build it. So we also provide the OVTF serving, which is a superset of TF serving. So we have already pre-built the image, and then so they can deploy the same way they deploy TF server. So you're given the steps on the Docker page, which Kumar just shared, and then you can run it all your TensorFlow workload with it. And if you want to enable OVTF, you have to just pass an extra environment variable, and that just set you for using TF serving with OVTF. There's no extra step required.
Yeah,
Okay.
this is the page, guys. Yeah, let's
Excellent.
go ahead with the question.
So basically,
so
the summary of the last thing was that instead of TF serving, you could use OVTF serving without, I mean, they are almost identical. So with almost no work, you can get that benefit.
Exactly.
Okay. Okay.
Excellent.
And
we've
we
got
have
a
that
ton of
environment
questions here
variable,
today.
TF enable and disable.
Yes.
There also we can pass and just makes everything working.
Yeah, so we're a little bit over today. We've got a bunch of questions, so let's see if we can get to a couple of them. First, a couple of comments. Rahul says this lecture is very useful. Thank you. Antonio just says great with an exclamation mark. Thanks, Antonio. So questions. Pankaj would like to know, I think you already answered this one, but is there similar integration for PyTorch?
Yeah, we do have. That's called OpenVINO TORT, torch on external.
Excellent. Quick answer. Sesu would like to know, are there any plans to utilize CUDA to leverage non-Intel GPUs, or is this not really on the roadmap for this tool?
Yep, CK.
So if you're using OpenVINO TensorFlow, so the thing is like for a single model, it is difficult. That is, I mean, you don't have, you would be have to be at a very advanced level to divide even the single model and place it or execute it separately. But normally for a single model, you cannot use CUDA and the same thing both, because the falling back is right now not enabled for the NVIDIA GPU. The fallback would be on Intel CPU. But if you have multiple model and you've designed your application that one workload which is very heavy and you want to run an NVIDIA GPU, you can do that. Okay, OVTF to disable and then model.predict, and then that is on NVIDIA. And then you do OVTF to enable, and then you can run the next workload on your Intel CPU. So that way you can smartly divide your multiple workloads on your availability of hardwares.
Great, yeah. Thank you. Richard would like to know, how do you guarantee repeatability and reproducibility with all the different variations in hardware and different levels of precision optimization for these different pipelines? Is this something that you think you spend a lot of time on in developing or scoping these sorts of things?
So there are two things to it. One is like the repeatability, and for that maybe what I assume is like given the run the different combination, then the output compared to native framework and then what you run on this combination, they are same. So this is like part of our internal validation itself. We don't release it until we get that to that standard, and that's where we make sure that we are not deviating away from TensorFlow's output. So that's one thing. And then the next thing is like the improvement. I'll like to take that part. The performance improvement will keep on improving as you move to, or like because like the product move to the next stage. So that is where you could see a lot more coverage and then maybe a lot more options you enable. For example, so right now we don't have quantitation enabled in OpenVINO TensorFlow, but then in the next stage you will get even that too. And there also we'll make sure that the accuracy loss you have through quantitation won't be like or it will be comparable to TF quantitation in that way.
Richard would also like to know, is OpenVINO working in Ubuntu with WSL2?
Yes, I like you can use even OpenVINO as well as OpenVINO TensorFlow both in WSL.
Awesome. Great.
There's a question about
ahead,
AMD processors also. This is in the chat, whether OpenVINO works on AMD processors.
So I'll talk about OpenVINO TensorFlow first because we are can say a subset of OpenVINO hardware support, and we support only the Intel devices, and that is because we day in day out work on. We know that these are the 4 devices which I mentioned we support. OpenVINO does has a extra coverage, and I would say for their any future release guidelines or maybe features, we can the users can follow the OpenVINO release page, and there they can get extra information.
Okay.
Cool. Yes, excellent. We've got one more from Sesu here, or Seshu, who'd like to know: are there any benchmarks comparing these Intel GPUs with OpenVINO versus, say, NVIDIA GPUs with TensorRT with regards to inference speeds that you're aware of? Comparing these two.
So one thing I want to add here is that I don't know about benchmarks, but it may not be apples to apples comparison, because when we say Intel GPU, they mean integrated Intel GPUs. Intel also has GPU standalone, but I think they are only available in China right now. Whereas NVIDIA GPUs are standalone. So I don't know whether it would be apples to apples comparison, right? It's a different.
So
but
I would
sorry, I'll let you answer.
That's absolutely correct. I just wanted to add another dimension to it, that don't just look at FPS, because if you take an NVIDIA very high-end GPU and then you compare it with a CPU or maybe other integrated GPU, that's not a direct comparison. And the other metric, which could be performance per watt and cost or performance per dollar kind of thing, right? And if you're looking at those aspects, which is very important for edge workloads, and that's why this OpenVINO is so popular, and that's why it even motivated us to do OpenVINO TensorFlow, which can be used for all the edge workloads too.
Then you probably get more bang for your buck with the Intel workflow.
Exactly, spot on.
Yeah. All right. Yeah, we're getting very near the end here. Our guest next week we will announce on Tuesday. It's a secret currently. Satya, you want to take us home?
Yeah, I want to add a little. We talked about the MS Coco dataset. I want to give a little assignment or a little tidbit about the MS Coco dataset. There are 80 categories in the dataset. The last category has, and they are serially labeled 1 to 91. So something for people who are beginners, go dig out why there are 91. The last index of the last class, the hairbrush class, is 91. But there are only 80 classes. So some homework to do, some interesting tidbit.
Oh, wow. Please do that. And maybe we'll reserve some time next week to ask folks what the answer to that one was. Maybe it'll be a second trivia question or something like that.
All right. So that's it for today. Thank you so much, Kumar, Vishwesh, and Chandrakant, for this excellent presentation. I learned myself. This is something new that I learned because we have not used it until now. I'm very eager to go and check it out and tell my team about this as well. And as always, Phil, thank you for organizing this.
Mm-hmm.
And
thank you.
Our audience, thanks a lot for encouraging us, coming here and listening to what we have to present. It means a lot to us. Thank you so much.
That's right. We wouldn't do these if you didn't watch them. Quick shout out to Ragesh for facilitating this webinar. I'd like to encourage everybody out there to do as I do. Live every week like it's Shark Week.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.